Hey everyone, in this video we're going to take a look at the coding agent under the hood and try to understand how it actually works. The first time you see an LLM not just answering questions but running commands and making changes across a code base that actually work, it feels like a huge shift. And thanks to open source and the great work from the Opencode team, we get to explore that in great detail. So let's dive in. So the basic workflow is as follows. You install your coding agent. In my case, a brew install does the trick. Then you configure your API key so the agent can interact with an LLM. The cool thing about Opencode is that it's provider agnostic and it supports a bunch of models, even local ones, as long as they have an OpenAI compatible API. So that's pretty cool. So we do that as such, and we provide the API key. And then once you've done that, you just start the Opencode command inside your project's repository. So in my case, I cloned the Opencode repo and I'm running Opencode inside the Opencode repo. So we got a little inception thing going on. So once you run the command, you're faced with this TUI, this text user interface, and you basically ask the agents to do things. You can ask it to analyze the code, to build a new feature, to fix a bug. In my case, I'm going to ask it to transform this and make sure it does not make any mistakes. Anyway, so while doing this, the code has access to tools so it can read files, modify files, run commands, and all that. So how does it all work? What are we exactly trying to accomplish? So we have a project that contains several code files, and we want to interact with a large language model or an agent and have it modify these files, read their contents, analyze the code, and perform various actions. So the key principle is having the LLM interact with our files. And the way we do that is by providing the LLM with tools. So the way this works is when we call a model, so this is, for instance, the Anthropic documentation, we can provide it with a list of tools. So here we give the get weather tool its description, its input schema, and if we check out the OpenAI documentation, it has a similar construct, a get weather tool, a description, and a parameter. And these models can do more than just calling the get weather tool. The model companies are apparently fascinated with the weather. Anyway, so we give the model a list of tools. We describe what the tool does, what parameters it's expecting, and then when the model deems the tool call appropriate and relevant to the current task or to the current prompt, it will actually output the name of that tool. And the runtime environment, so the code that's actually calling the LLM, will execute that tool call. So the developer wants to make changes to a project. So they start the Opencode agent and they are faced with the front end, the TUI, the text user interface. The developer submits a prompt, which is sent from the TUI to the backend, so the processing can actually take place. So Opencode is architectured as a server-client application, with the TUI being the client communicating with the server over HTTP. The application also has an event bus. So whenever something meaningful happens in the backend, it gets published to this event bus. And you can have events published to the event bus, but you can have also different parts of the application that subscribe to the event bus and to certain events, so they get notified of these events. The HTTP server also exposes /event endpoint, HTTP endpoint, that HTTP clients can connect to. So the TUI, the front end, connects to this /event endpoint. So when I started my Opencode agent, an HTTP server in this was started in this port. And when I connect to the /event endpoint, I get this. So if I type something into the TUI now, for instance, events get sent in the SSC endpoint. And so the way it looks in the code, so there is this /SSC /event endpoint, which has a content type of event stream. and it subscribes to all the events that are published to the event bus, and then they are streamed back to the clients, to the HTTP clients. So what this means is that if the client sends a prompt and the work takes a long time, so the client is gonna be updated as events happen in the backend. So it does not have to wait until things finish, but it's gonna see the updates as they happen because they are published from the event bus to this SSE endpoint. And that's pretty cool when you think about it. And the Golang TUI listens to these events, and as they happen, it updates the TUI. And when there is a permission that needs to be granted, it shows it to the user when there is an error as well, and so on. So having access to tools and to the local environment is what differentiates a useful coding agent capable of accomplishing tasks from a vanilla LLM. Opencode comes with a list of built-in tools very much similar to the actions that a developer needs to take in their day-to-day. So you have a bash tool to run bash commands, to inspect files or move files or copy them. You have an edit tool to change the content of the file. You can read files. You can create a to-do list. You can fetch content from the web, so you can look up information in some documentation, and a lot more. In addition to these built-in tools, uh, Opencode allows the ability to plug in MCP servers. So having the ability to add an MCP server, either locally or a remote one, and then load up the tools and the resources this MCP server has to offer is a pretty powerful capability. And this means you can easily extend the capabilities of your coding agent. So let's explore the tools. To make things a little bit more concrete, so I had a session with Opencode, and I actually wanted to make some changes to Opencode itself. So as we previously described, currently Opencode has a TUI client, so that's a text user interface in the terminal. And since it has a client server HTTP model, I thought it would be fun to build an HTTP client that's gonna call the Opencode backend from the browser. And so I started this session to add a new endpoint to the HTTP server that will serve a client that would interact with Opencode through from the browser. And now when I connect to the HTTP port exposed by the Opencode server and go to the client endpoint, I can actually see an HTML client, which is pretty cool. And after a few prompts, it was actually capable of generating a semi-working example, which is pretty impressive. I think I was using Grok code. So anyway, so let's take a look at the tools. Maybe we can explore the conversation a little bit first. So I asked it to add new HTML server endpoint in the server.ts file. It prompted me for my permission to allow this change, and I approved. So it's called the edit tool. And then I was not too happy. It had some errors, so I provided the error trace and asked it to fix it. And then I asked it to improve the style, and it had some linting errors and all that. And at the end, it was actually capable of providing a working example that's capable of listing the sessions. So a session is basically a conversation between a client and the backend server. And when you start a new session, you start fresh from with a fresh context window. And so when you click on a session, it fetches the messages within that session, and you can even send, which is pretty cool. So anyway, let's take a look at the read tool. So a tool definition is rather simple. So we need to have the description of the tool, and this is basically informing the LLM of the capabilities of this tool. So the description of the read tool is reads a file from the local file system. You can access the file, blah blah blah, and you can and it has an offset parameter. So for very big files, you don't want to read the whole file because you're gonna saturate your context window. So you want to be able to read with the limit. And sometimes when you have an error in specific line, you don't want to read the whole file, but start from that specific or before, just before that line. So the read tool has these two knobs that can be tweaked by the LLM, the offset and the limit. And it's not as simple as reading the file. You need to make sure that the model is not accessing the file outside of the current working directory. Otherwise, this could be malicious or harmful. We need to check for images and binary files, so we're not reading incomprehensible data, and some other checks. And finally, we give the output of the read operation to the model. So in Opencode, we have a session. That's the whole conversation. Each within the session, we have messages, and each message is composed of chunks or parts. So what we're looking at here is a part of a message, which is a tool response. So we can see type tool, and the status of the call is completed, and this is a read operation. So when I asked my agent to make changes to the server.ts, the LLM decided that it needed to read the contents of that file. And so the LLM generated a tool call. And then the JavaScript backend, the AI SDK, called the execute function of the read tool. That execute function actually read the file from the file system and added it to the context of the LLM, and the LLM is now able to read the file. And that's what happened. And we can see here that the LLM wanted to read starting from line 150 and read only 30 lines. This was not the first call, I believe. This was at one of the iterations, but it gives a sense of how it actually works under the hood. So that was the read tool. The bash tool is very similar. We define a tool. We provide its description. So the bash tool description goes like this: execute a given bash command in a persistent self session, and then we specify information about how the paths should look like, about how to call certain commands. That's the description. And then running the command, so that's actually the execute command, we can see that the bash command sometimes requires permissions. And so if the user's permission is needed, we ask for it, and basically the user is prompted in the terminal. Do they accept or deny the permission? And if it's granted, then we execute the command and we get this process variable. Then we take the standard output of that process and the standard error, add it to the result of the execute function, and we return that to the LLM, and that's added to the LLM. So the bash command is executed, and the output of that execution is added to the context. For me, the to-do tool is one of these things that when you see for the first time, you are in that wow effect moment, and seeing a coding agent create a to-do list and they starting to cross off items from the list was really quite impactful. So anyway, the way Opencode implements the to-do tool is, as always, we have our description, and there are two tools within to-do. So we have the to-do write, in which we update the to-dos, and the to-do read, in which we read the actual to-do. The LLM provides a list of to-do infos to the tool, and the tool simply has a global map of to-dos, and it for each session ID, it assigns a list of to-dos. So the LSP tools is, in my opinion, one of the most powerful tools the agent has access to. So LSP, Language Server Protocol, is what allows us to have information in our IDE about our current project. So when we add a variable name that does not exist, or we make some syntax error or whatever, we see this squiggly red line in the IDE or warning or whatever, and that's thanks to LSPs. And the diagnostic message from LSP looks something like this. So for instance, if we have a variable that's not defined that we are using, the LSP client, our editor, would get a message from the LSP server as this. And it says that this variable is not defined. So Imagine this. Each time the coding agent makes changes to the code, to a code file, the LSP server checks these changes, and if it does not adhere to the language rules or if there's something wrong with it, it emits a warning. That warning is added to the LLM's context, and so it can see in real time if its changes make sense or don't. And the way Opencode implements this, so when it starts, it launches an LSP server for various programming languages. So for Python, it launches a Pyrite server, and for Golang, it has a Go PLS server. It has a Ruby LSP server, and so on and so forth. And the LSP server and client communicate through standard I/O using JSON RPC. So the messages between the LSP client, in our case, it's an embedded client within our in our case, it's an embedded client with their own coding agent. It communicates with the created LSP server using standard I/O. And so when the edit tool is called, within it, we have a call to the LSP server to get the diagnostics, and it looks something like this in the code. Here we are within the edit tool function, and after we write our changes, the new content, we get the diagnostics from the LSP server and add these to the LLM's context. And what does this look like? So in terminal interface, we actually see the errors as part of the edit tool. Once the edit tool is called and the LSP diagnostics have been retrieved, the LLM sees in its output this file has errors, and then we see the exact errors as output by the LSP server, which is pretty cool. And I think this is one of the reasons why coding agents are a great application of LLMs, because there is already so much tooling and many guardrails. So if the LLM makes up something nonsensical or hallucinates, the LSP and other tools are there to keep it in check. And one other thing the LLM can do is it can run tests. So after it makes some changes, it runs npm run test. And then if there is a failure with the test, that can be seen within the output, and the model can adjust accordingly. Many people like to say that agents are simply LLMs in a loop with access to tools. This is what I like to call the $1 trillion loop. So where is our $1 trillion loop? So we have a system prompt, we have defined tools. Now we actually need to call the LLM with these tools and act upon the response. So the way Opencode does this, when a user submits a prompt in their TUI or in a different client, this goes to as a message that is created via the HTTP endpoint. And then we call the session.prompt function. Within that function, we bring in the various tools and the system prompts and all that. Then we call the AI SDK stream text function. So the stream text function provided by the AI SDK, and which is of course provider agnostic, streams the model's result as they are happening. So we don't need to wait for the whole generation to finish. We can see it as it is progressing. And under the hood, it's implemented using JavaScript generators, and it's a pretty cool implementation. But anyway, as these stream text results are arriving, our backend, our JavaScript backend, is handling the responses. So whenever there is a tool call emitted by the LLM, the backend actually calls that tool when there is and gives the tool result back to the LLM, and it keeps progressing. And in our case, as these events are happening, they are also streamed from the HTTP backend to the front end, to the TUI client, and to any other client that is subscribed to the /event endpoint. And so this is at its heart the coding agent process. So we submit the prompt, we define the tools and the system prompt and the user prompt, and then this is sent back to a model using the stream text function. And as the results are received from the LLM, we process these results. If it's a tool call, we actually call that tool and provide the result of the tool call back. And it keeps progressing. If we need a permission for a certain tool call, as it's defined within the Opencode configuration, we ask the user for their permission, and it keeps happening, which is pretty cool. The processing loop looks something like this. So depending on the type of the stream response item, it could be a tool call, it could be a tool result, a tool error. For instance, if it's tool error, we decide that we should stop this stream. And if it's text delta, and so on and so forth. And one cool thing is that the stream text function is capable of making multiple tool calls. And so each tool call is considered a step. And we can specify within the stream text parameters that we want to stop after a certain number of steps. So here, for instance, we say stop after 1,000 steps, which seems like a lot. Or if a certain condition is satisfied, in our case, we should stop if there is an error. And so after each step starts, what the Opencode processor does is it takes a snapshot. And what this snapshot does is it takes all the change file in the Git repository and dumps the changes into a snapshot directory using this track function. So we add the current files to the change files to the index, and then we write the tree. And if there is an error or we want to revert for whatever reason, we just read the snapshot and we retrieve our previous state. And this is very much similar to what a commit does, but this does it without actually altering the commit history. When Opencode interacts with an LLM, it does that within the context of an agent. So an agent is an LLM plus an additional agent-specific system prompt plus a set of tools. So we have the plan agent, which is used to plan tasks and analyze a problem and outline a plan. We have the build agent, which relies on a plan or can figure out the problem itself and actually make changes, whereas the plan agent does not have access to edit tools. The build agent does. And we can define our own agent. So we can define a review, an agent that reviews code. We can define an agent that specializes in security. And each agent can have its own model, its own tools, and its own temperature and all that. So there is a very interesting tool called the task tool that a primary agent has access to. So the task tool's description reads like this. This is a tool. So a task tool is a tool like any other. And its description says that you have access to certain agent types. And these are the sub-agents that are defined by the user or within Opencode. And whenever there is a task that's an independent task, for instance, if we ask our primary agent, the build agent, to check for security vulnerabilities, and we have defined a security sub-agent, the primary build agent is going to make use of the task tool to call that sub-agent. And that sub-agent will have its own context window with potentially a different model, and it's going to run and call its own tools. And when it's done, it's going to return to the primary agent. And this is just one sub-agent. You can have multiple sub-agents. So if we ask the LLM to review the primary agent to review the code for vulnerabilities, but also for a regular code review, it could spawn two sub-agents, which are basically two tool calls. They can run on their own LLM context, and then they return. And having these sub-agents is what creates the whole agentic workflows. It's pretty interesting. So the way a developer interacts with Opencode is through TUI, a text user interface, which is beautifully designed and rather smooth, and it's written in Golang. One thing that intrigued me when I was exploring Opencode is how they made the Golang TUI play nice with the JavaScript backend and how they wired the two together, and it's rather nifty. So the way they do it is they build the Golang binary, the TUI, into a binary file, and then that file is imported into the JavaScript code. And Bun has this cool command, bun build compile, which basically builds your application and it packages this with its dependencies and the bun runtime into a standalone binary. So we have a single binary that has the bun dependencies, the bun runtime, but also the TUI embedded. So when a user runs the Opencode command, they are actually running the bun standalone binary. The binary will start an HTTP server, then it's going to look within its embedded files for the TUI binary. That TUI binary then is started, so we spawn a new process using the TUI binary, and that process inherits the standard output and standard input of the bun process. So when we interact with the command line, we are actually, when we interact with the terminal, we are actually interacting with the TUI process. And within the Golang startup method, so this is the main function of the Golang binary. And within it, we have this HTTP client that's going to call the list streaming method. What this method does basically, it's going to subscribe to the /event endpoint that we saw at the beginning. And so each time an event happens in the backend, it's going to be streamed from the HTTP server to the TUI's HTTP client. So where do we go from here? Exploring the code has been really interesting, and I believe we barely scratched the surface. One takeaway for me is that it's really hard to build a good product with a good developer experience and a well-architectured app. So kudos to the Opencode team. I hope this has been informative. Thank you very much for watching. Bye-bye.